All right, limits at infinity. Limits at infinity tell us about horizontal asymptotes. So if you take the limit as x approaches infinity and you get a number, it's going to tell you that we have a horizontal asymptote. That's the main. So the two main things here are looking at where are horizontal asymptotes and what happens to functions and their end behavior. Are you gangster now? What up, G? Let's take a look at y equals 1 over x. So conceptually, okay, we're chit-chatting a little bit much, everybody. Knowing last year how much we struggled with this, we need to pay attention. Yes, the limit as x approaches infinity of 1 over x. You can see on the graph as x goes to infinity, we get close to 0. What about negative infinity? Okay. Okay, horizontal asymptote at 0. This basic example kind of provides you with the basis of what this is all about. So what happens as we go left or right a long ways? You can do it graphically, numerically, and I'm going to show you a couple ways to do it algebraically. What about sin x? Who are you talking to? Yeah, exactly. Leon. It's not undefined. What would we? It's what? No.
It goes to one and it keeps going. It doesn't. It just goes up and down.
Yeah, I think you have the right idea, but you're using the wrong words. All right. So if it's non-existent, what do we say? Because it oscillates. Okay. It never settles down on some one number, so that one does not exist.
I feel oscillate. Thank you.
Do you write D&E for that or oscillate?
D&D. Because it oscillates.
The limit is not oscillates. Okay, that doesn't make any sense. It makes complete sense. does not exist.
Just write on your test.
Wouldn't there be dots in every letter though? No, acronyms don't have dots.
All right, children.
I just meant see dots everywhere.
So do you want to solve this?
So check this one out. Those are negative exponents. So if you get negative exponents, it helps me if you rewrite it. If I rewrite it, you don't have to, but
Yeah.
that helps me see plainly what the answer is. What is, oh, wait till you're
It's
done writing.
approaching,
3,
What does that one go to?
0,
And this one?
0,
And that one?
3.
Oh, that would be minus.
wait, how do you figure out that something's 0?
Well, it's 4 over a really big number.
Oh,
So it's like 0.000005.
I see
Right.
that, because 4 divided by some huge number.
And then some huger number, and then some, well, larger number, and some larger number. So it keeps getting smaller and smaller. So algebraic, or graphically, it looks like this. This is what it does algebraically.
Wait,
So,
so 4 comes from after 3?
yep.
Okay. Oh, no.
You'll see that notation.
Is that from the left and right? Is that what that means?
So what we have in this problem is plus or minus infinity. It basically says take 2 limits. Okay, so we have 2 different problems here. Yep. Okay. Does anybody intuitively think they have an idea of what this is all about?
From the left and right?
Factor.
You can try to factor, but this one, yeah, no. When you get messy polynomial rationals, we're going to do 2 different limits is what we're saying. So when you get a messy polynomial over a messy polynomial, okay, the rational functions, divide each by the highest power. I know you trig students saw this last year. In the denominator. What's that? X to the 5th.
Oh, yeah,
All right, so yeah, it looks kind of ugly.
How can you make it this far? Well, then you know that's the bottom of part is 0, right?
So let's divide them out. What do we have here? Oop, that should be a 5.
3. Oh.
And
3
then
minus 4 over
the negative
X
one is
squared.
going to be a little bit more.
So then the bottom part is 3?
Yep. So 0,
0, 0, 0, right? And it doesn't matter positive or negative infinity. Okay, are you with me so far? Calm down, children. Where are we stuck?
Gotta write it down.
Okay,
Why do you cross out the two top ones?
because they go to 0. 20 over x cubed is 0, 0. So don't hurt anybody, Corey.
I should take a look at it. So horizontal asymptote is 0? How do you know if it's vertical?
A vertical asymptote will say like the limit as x approaches 0 is infinity. So if you approach an x value, it's positive or negative infinity.
Okay.
Let's try another one here. These ones are a little bit funky. Yeah, so x squared over the root of x cubed plus 1. What you want to know is what this denominator does.
It helps you infinity,
Okay, it's pretty darn close. It behaves like x to the 3 halves. The plus 1, and when you get to infinity, adding 1 is very inconsequential. It's just a grain of sand, right? Pretty much. So we need to
Oh, that's doing like a 1. Okay.
kind of manipulate this.
That I wanted to get better away.
Yeah, it's gone. Bye-bye. So I have taken an x cubed out of each of these terms. I factored it out. So I have x cubed times 1 plus 1 over x cubed. I took an x cubed out of each term. So I get 1 plus 1 over x cubed.
Oh, okay.
And then I'm taking the x cubed out of the root, because that's kind of what it behaves like, right? It's kind of hard to wrap your head around some of these, but we're looking at the behavior of a function, not the exact value, but the behavior. What is x squared over x to the 3 halves? So do you guys know where I got 3 halves? Okay, I had a cubic in here, right? What's the square root of a cubic? It's a fractional exponent, 3 over 2. Because this is to the 1/2 power. Remember, square roots to the half? So x cubed to the 1/2 power is x to the 3 halves. Okay, and then this is the quotient law of exponents. 2 minus 3 halves is 1/2. So what does the top go to? Okay, plug infinity in, it goes to infinity. And the bottom, this goes to 0. So 1 plus 0 is 1.
Wait, infinity? Okay.
So you're basically looking at function behavior, not being mathematically perfect.
So that's a vertical asymptote at 1? Would that be a
No, because it's the limit as x approaches infinity. It looks like that. As x goes to infinity, so does y.
Oh, okay.
Yeah.
Then how would you know if it was just a vertical asymptote?
Okay, if Delcia brought up a question that I can answer with the example from the first part of class today. If you want a vertical asymptote, you're approaching a number on the x-axis, and the answer, let's go 0 from the right, is infinity. The limit as x approaches 0 from the left. Okay. We know there's a vertical asymptote there.
Okay.
Okay. The graph never touches it. Okay, where are your brains on this one?
What is the question like? Well, you have to go up and
Let me show you one more, and then we'll see if that helps. Okay, limit as x approaches infinity. 12x plus 25 over root 16x squared plus 100x plus 500. What does that make the largest exponent in the denominator? Right. Okay, so here's a different approach to it. The bottom exponent is x to the 1 because it's the square root of x squared. Right? So we're going to divide everything by x.
Wait, where did you get this x?
What's the square root of x squared?
Oh,
See x squared and the square root of it.
okay.
This is probably a better way to come about, huh? Oh, this would be, now be aware here in the denominator, you're putting it inside a square root, so it has to be x squared. All right?
So then the bottom approach is 15, and the top approach is 12, the bottom approach, right? Oh, yeah. And the top approach is 12? So that would be 3? Oh my gosh!
Is that better?
We got it, guys!
Oh, somebody has it. The best thing I could probably do is shut up and let you start working and answer questions. So, I'm probably going to delete some stuff out of this. So I'll write it down and then look at it because it's probably too much. That's the lot of it, unless I delete something. Skip 1-5 for now. I'm going to look at something on the AP test to make sure it's. Yeah, start at 7. Take out 31. Take 1 and 5 off. We're just going to take a risk there.
That should be a little better for you guys tonight. Gets what we need to get.